Okay, so we're using our prior knowledge to match these up. Yes? Equiangular. Which one is equiangular? Yes. Equiangular is B because the definition of that word is exactly how it sounds. Equiangular, equal angles. So all three angles are equal. Let's take this one step further. You already know the triangle angle sum theorem. I bet you already know it. And so if all three angles are equal, what is the measure of each angle? Good, 60. So if it is equiangular, then each angle would be 60 degrees. Okay, name the triangle that is acute. Very good. F is acute because all three angles are less than 90 degrees. 90 degrees. All three angles measure less than 90 degrees. Number 3 is ridiculously easy, right? Okay. A for number 3, that is a right triangle. It only takes one angle of a triangle to make it a right triangle. Could a triangle have 2 right angles? No, it couldn't have 2 right angles because 90 plus 90 is 180, and a triangle only gets 180 degrees. So it would have used up its quota, and then the third angle would be 0, and there's no such thing as a 0-degree angle. So number 4, which one is obtuse? Y'all were ready. Y'all are just waiting for me to ask, and you have it ready to go, don't you? C, very good, because 120 is greater than 90 degrees. Equilateral. D. Equa means equal, and lateral means of a side, so equal sides. Isosceles. Y'all are cracking me up. G. Very good. We'll learn later that isosceles means we have at least 2 sides congruent, so that's what those tick marks display. And then finally, the last one. Do you know how to pronounce this one? You say that one scalene. Well, you're typing it, but I'm asking if you know how to pronounce it. You pronounce it scalene. That means no sides are congruent. Okay, so we've pretty much covered the vocab, but let's go through it one by one so that we make sure we feel good about this. Just going to skip that one. So there are 2 ways to classify a triangle. When I say classify, I mean to categorize it, right? To name it. Just like you have a height and a weight, triangles have sides and angles. So we can name it based off of its angles, and we can name it based off of its sides. Okay? So first we're going to find out what all the different options are if we're going to name it based off of its angles. Okay, so Alton is raising his hand. So I bet you feel good about most of these. These are all names that are going to refer to its angles. So I'm going to click on these, and we've already pretty much talked about them on the last slide. Ready? The first one, all angles are equal. That would be, oh, come on. It's thinking. Equiangular. Very good. All angles measure less than 90. That would be acute. One angle measures 90. That would be right. Adriel, I can talk to you about that when class is over, not in the middle of a lesson, okay? And one angle measure is greater than 90. Obtuse. So those are our options if we're going to name it based off of its angles. Is there any overlap going on here? Or are those just 4 different categories? Acute and equiangular. So, equiangular, we already went over. We know the measures of those angles. We know that if it's equiangular, this one's 60, 60, 60, right? So, is an equiangular triangle always acute? Is an acute triangle always equiangular? Okay. So, if I asked you to draw a Venn diagram with these words, we would have acute, and then we'd have obtuse because there's no overlap there. We'd have our right triangles, But then where would I put equiangular? Would equiangular go like that? Does it overlap with acute? Like that? Or would equiangular completely fall inside acute? Yeah, because if it's equiangular, its angles are 60, 60, 60, and those are always acute angles. So that's what a Venn diagram representation would look like. All equiangular triangles are acute, but not all acute triangles are equiangular. There's lots of acute triangles that fall here that are not equiangular. All right. We can also classify a triangle by its sides. There are only 3 different options here, and I bet you know all of them. The first one, equiangulars. First one, all sides congruent. Equilateral, 3 tick marks. Look at the definition for this second one. Are you looking at that? Is that kind of weird to you? It doesn't say 2 sides congruent. It says at least 2 sides congruent. Isosceles, at least 2 sides congruent. And 0 sides congruent, no sides congruent, no tick marks at all. Scalene. So the emphasis here is that isosceles triangles have at least 2 sides congruent. So isosceles triangles could have 3 sides congruent. So there is some overlap here as well, because isosceles triangles can sometimes be equilateral. Good, Avi. Very good. So that leads right into this slide right here. Always, sometimes, or never. An equilateral triangle is isosceles. Always, sometimes, or never. A triangle with 3 congruent sides, always, sometimes, or never, has at least 2 congruent sides. Well, 3 is always at least 2. Always. Every time 3 is at least 2. Next one. An isosceles triangle is equilateral. At least 2 is always, sometimes, or never 3. Well, if it's at least 2, sometimes it's going to be 2, and sometimes it's going to be 3. Keyword, sometimes. Cool. It's never 4. Oh, silly. Okay, we already went over that. All right, just for fun, let's do some easy ones. I know those angles on number 4 got so small, but we don't really need to know those 2 angles. I don't know what happened to them. It's like last year they looked fine, and this year all of a sudden I opened up the file and they were like minuscule. Okay, number 1. Let's call names. V. V, number 1. Quinn, number 2. Very good, V. Quinn, number 2. Alexandria, number 3. No, try number 2 again, Quinn. So if I give you sides, I want you to name it, classify it by its sides. If I give you angles, I want you to classify it by its angles. On number 4, I said it doesn't matter what those angles are. This one's 125. That's all that matters. Equilateral, thank you. Alexandria, did you get number 3? Scalene, very nice. And then Abbas, do number 4. No, if I give you angles, you need to name it, classify it by its angles. Each one of these triangles has 2 answers. They do. But I want you to choose the answer based off of the angles. Okay, Adriel, just a second. Abbas, you don't need to see all the angles. I told you this angle right here, and that's all that matters. That's all that matters. Come on. Good. Obtuse. It is an obtuse triangle. It only takes 1 angle to be obtuse to make it an obtuse triangle. The other 2 angles are going to have to be acute. They have no other choice but to be acute. Adriel, equiangular has the word angle in it, so it means equal angles. And equilateral means equal sides. That's the only difference. I gave you sides here, and I gave you angles there. That's the only difference. If a triangle is equiangular, it is equilateral. And if a triangle is equilateral, it is equiangular. But that's not the focus of the lesson today. Okay, 3 more. Ariana, do number 5. Dustin, do number 6. And Lars, do number 7. Right, very good. It is a right triangle because I gave you a right angle. Dustin? No, Lars, it's not scalene. Acute, very good, because all angles are less than 90. It's so cute. You're right. Okay, Lars, what's number 7? Abby, that's not nice. Number 7 is isosceles because 2 of the sides are congruent. isosceles. When 2 or more sides are congruent, it's isosceles. And if all 3 sides are congruent, you would call it equilateral. You wouldn't call it isosceles. Okay? So number 7 is isosceles. Okay. You want to watch a quick? We'll see if it comes up. All right. Triangle angle sum theorem. I know you know this theorem, but I wanted you to see what it looks like visually so you can make that visual connection in your head, okay? So I took a triangle that's completely scalene. It's acute, it's scalene. There's nothing unique about this triangle. It's a random triangle. Yeah, there's no way you can hear that. Okay. Well, we're going to try. Okay, so like I was saying, sorry about that. No matter what type of triangle I were to throw at you, you could take the 3 angles, you could juxtapose them, you could place them next to each other, adjacent to each other. 1, 2, and come on, pink angle. 1, 2, and 3, and voila! You can see visually that the angles of a triangle add up to 180 because when you place them adjacent to each other, you get a straight line, and we know that a straight line has 180 degrees. So there's a visual of the triangle angle sum theorem. Let's put it into practice. Find the value of x and then plug it back in and find the measure of the angles. So am I insulting your intelligence? 75 plus 2x plus x equals 180 because the angles of a triangle add up to 180. And so we would combine like terms. We would solve for x and you get 35. Very nice. X is 35. And so when you plug it back in, this angle is 35. This angle is 70. What kind of triangle is this? Acute. For now, it's just acute. We will learn another day that it's also scalene, and I know you know it's scalene, but it is an acute triangle because all the angle measures are less than 90. All right, try your hand at this one. Okay, very good, Ganesh. We would probably solve for y first. Y is 36 because these 2 angles are a linear pair. So you would do 180 minus 144 and you would get 36. Then you would use the triangle angle sum theorem. You would add up 72 plus 36, subtract it from 180 and you would get 72. So what kind of triangle is this? Graham, what kind of triangle is it? Very good, Graham. It is an acute triangle, and yes, I know you're all saying isosceles because you know that if 2 angles are congruent, then the sides opposite are congruent. So it is acute in isosceles. Very good. Okay. So here was the warm-up from today. This one was kind of weird. It didn't ask you to solve for x. It said write an expression to represent angle A. So if we know that x plus 7 is the measure of B and C, so this is x plus 7, this is x plus 7, and we need to represent angle A. Then we would just write an expression. So we're not solving for A. In fact, we can't solve for A. We have no idea what A is, but we do know that we can do 180 minus x plus 7 minus x plus 7, or x plus 7 times 2, if you want to look at it that way. Good, yes. So you could put it that way, 180 minus 2 times x plus 7. Just be careful that when you distribute 180 minus 2x minus 14, make sure you distribute the negative 2, not just the 2, but distribute the negative as well. So if we clean that up a bit, it would be 166. And I know, Rishi, I see that you're talking about the wording. I know the wording might have been a little bit confusing. They were supposed to each measure x plus 7. So 166 minus 2x would be the correct answer. And I know the wording was a little bit weird. So if you did do the homework last night, these are the answers. If you did not, you can just look at this tomorrow. So those are the answers to the triangle sum theorem, and then we're going to move on to the next half of the lesson, okay? Okay, so diving into the second part of the lesson. This part of the lesson actually is just a shortcut. I'm going to teach you a shortcut. It's not necessarily imperative that you know this theorem, but it makes your life easier and it makes problems a lot faster. So I call this the shortcut theorem. This is a theorem that people easily forget. You easily forget to use this theorem, but it makes your life so much easier. So practice this theorem on the homework tonight. Do it like 10 times in a row so that this is ingrained in your brain and you don't forget about this little shortcut that I'm about to teach you. Okay? Exterior angle theorem. So first we need to go over a few vocab words so I can call these angles something. In a triangle, this angle would be an exterior angle because it's on the outside of the triangle, right? And then the two angles furthest away from the exterior angle are called the remote interior angles. They are at a remote location, just like y'all are at a remote location as I'm teaching you, right? So those are the remote interior angles. They're not the same measure, but they're both called remote interior angles. They're the two angles that are not adjacent to the exterior angle, okay? Now, there's a theorem that says if you take the two remote interior angles and you add them together, guess what it equals? Angle 1, angle da-da-da-da. See if I can get this right. A little more twisting, Miss Stanton. There we go. So what's the measure of angle 1 plus the measure of angle 2? It's the measure of angle 4. The sum of the remote interior angles equals the exterior angle. It doesn't equal 180. It doesn't equal 90. This one plus this one equals that one right there. Those two angles perfectly fit into that exterior angle. So that is the shortcut theorem. Remember, I call it the shortcut theorem. Oh, don't look at this. That's wrong. Measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. Let's not look at that. Delete, delete. Okay. The measure of each exterior angle equals the sum of the measures of the two remote interior angles. So the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. So angle 3 is not involved. You would not be using angle 3 at all. Okay, let's put it into practice. Number 10, here we go. Chloe, what is the measure of x? Chloe, what is the measure of x? Yay! 96. Very good. All she had to do was 51 plus 45. It's a shortcut. Could she have found this angle? Could she have added those, subtracted from 180, found the purple angle, then found the linear pair of the purple angle? Well, sure she could have, but that's a lot more steps. This is a shortcut. Abby, what is the measure of angle x? I'm asking you to add here, guys. I know I'm asking a lot. Abby, what'd you get? All right, for number 11, we would add the remote interior angles. You would add them together, and that equals the exterior angle. So 90 plus 44 would get us 134-degree angle. So that's all it takes. You add the remote interiors, the one furthest away, and it equals the exterior angle. Alrighty, try this one. Now this one would be a tough one without this shortcut. This one would be messy, although you could solve it without the shortcut. Ooh, it would be a doozy. So go ahead and set up an equation for this one. So hopefully on this one, your equation, and by the way, this is a test question. If you want to go ahead and star it, it's a test question. 8x minus 25 plus 3x plus 11 equals 3x plus 26. Remote interior angles, you add them together and it equals your exterior angle. Okay, 11x minus, what, 14? Look at that. What does x equal? X is 5, very nice. And then if we wanted to, we could plug it back in and find the measure of each angle, but they didn't ask us to do that, so we won't do that right now. Oh, Rishi, that's not what I was saying. You can't see these markings, so I'll make them darker. Those are isosceles triangle markings. No, I said the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. I never said 1 plus 2 equals 4. That's just how I named the angles. Okay. So how are we going to do this one? $125. You want to start by doing 180 minus 70 divided by 2, right? Because those two angles are congruent, they're the same measure, so you can just take the degrees you've already used and whatever's left over and cut it in half. Yes? So 55, 55. And then from here, you have two choices. You could find the linear pair of 55, you could find the linear pair, or you could use the remote interior angle theorem, the exterior angle theorem. 70 plus 55. Either way, the answer is 125 degrees. Let's get a little bit tougher, just barely. Yes, that's what I was saying, Alton. You could have done the linear pair. Yes, you could have. Yes. I know we're already getting close on time, so I'm going to go ahead and start talking about this one. I would start by finding, well, there's a couple ways you could do it. There's a lot of things you could do on this problem. If we wanted to use our theorem, then this plus this equals 177, right? So 90 plus something, I'll call it y, equals 177. So we could do 177 minus 90. And then divide it by 2, right? Because that angle is bisected. This is just one way to do it. Are we getting a decimal? So this would be 87, but then it was bisected, so it would be 43.5. And now we can use the triangle angle sum theorem and just do 180 minus 43.5 minus 90. 46.5 is the answer. But another way to go about this, and I'm sure you might think this other way might be a little bit easier, you can find the linear pair to 177, which is, what, 3 degrees? And then you could say this plus this equals 180. So you could find the missing one, then divide it by 2, and then find x again. So whichever way you think is easier. Oh, and that's all. So your homeworks are triangle angle sum theorem and exterior angle theorem. Y'all have already taken both parts of the test, so you don't need to worry about that.